guys, I'm Kumar K, your favorite DSA mentor when it comes to solving hard unseen DSA problems of top tech companies' online assessment and coding contest problems. Today, we are going to solve a very interesting problem. This one, okay? It was asked in Leetcode weekly contest 429. We are going to solve the easy version as well as the hard version. Guys, coming to my introduction, I'm Kumar K. Previously, I worked at Amazon and Mir.net as a software engineer, cracked those offers off campus. And coming to our love for DSA, I have All India Rank 12 in Google Code Gem 2021 and All India Rank 4 in the recent Facebook Hacker Cup. Now, let's go to the questions. And before going to the question, guys, I want to congratulate my student Harini who has cracked off campus offer from Amazon just 1 to 2 days back. So, guys, this is Harini. Congratulations to her. She was trying from a long time. In the past, she failed interviews and OAs, okay, of multiple top tech companies, FANG companies. She was very demotivated, but she kept training with us for 10 plus months, daily life training, assignment, homework, one-to-one mentoring, referrals, all the things. Finally, she got selected off campus. Okay, she was from our November 2023 batch. So congratulations to Harini. And guys, there is a special offer for you people like who want my personal one-to-one mentoring, who want my 850-hour course on DSO ACP, and who want live training, referrals of top 500 companies, and many more extra features to improve themselves and make them strong in a nice, brilliant way. You can check the link in the description. Now, guys, coming to this video, if you like the educational content of this video, make sure you like and subscribe. Now, guys, going to the question. The question is pretty interesting. Okay, so let's make it easy for you. So guys, they are saying that a binary string is given to you, okay, and you're allowed to do less than equal to k operations on it, okay. In one operation you can flip a 0 to 1 or 1 to 0, okay. The task is to make sure that after all the operations are done, the length of the longest substring with equal characters is minimum, okay. So guys, they are saying that we are given a binary string, we are just given a binary string, and rest all is going pretty good. So let's say, guys, this is your binary string, okay. This is, let's say, your binary string, something like this, okay. This is the binary string. And they have given you k. K is the number of operations you can do. You can only do one operation. Now they are saying that whatever blocks of 0 and 1 you have, na, the size of all those blocks, the size of all those blocks should be uh, as small as possible. The block size should be as small as possible, okay. So in other terms, the largest block size should be as small as possible. The largest block size should be as small as possible. Guys, currently what are the block sizes? Well, here the block size is 4. Here the block size is 4, and here the block size is 3. So guys, on the left hand side you can see that the block size is 4. On the right hand side the block size is 3. Now guys, giving you some time, think what can you do to reduce the overall block sizes, or how to reduce the largest block size. Currently one block size is 4, another is 3, and the largest is 4. How can you decrease this largest block size? That's what we need to discuss. So now, let's try to discuss, guys, how can we do that. And doing that is actually very important, okay. So now, the most important thing is, guys, that you can flip a 0 to 1, right? So what can I do is, which is very interesting, I can change this 0 to 1. If I change this 0 to 1, if I change this 0 to 1, what will happen, guys? If I change this 0 to 1, now the string is looking like this: 0 0 1 0 1 1 1. Okay. Now, how is our block size looking like? This is the block size of 2, block size 1, block size 1, block size 3. Which is the largest block size now? 2 1 1 3. 3 is the largest. So now it is 2 1 1 3. 3 is the largest. So guys, 3 is our answer. Earlier the largest block size was 4. After doing one operation brilliantly in the middle, the largest block size has become 3 by doing one operation, okay. So guys, hopefully you understood that how nicely we can do the operations and try to decrease the largest block size. So, what is the observation when we try to go through this question? We will go through this example also, guys. See, one, two, three, four, five. So there are five zeros. Okay, let's do it for you, guys. There are five zeros. Okay, there are five zeros. Three, four, five. Five zeros and a single one. Currently, the answer is four. Sorry, this block of equal numbers, phi, and this block of equal number one. So, guys, what is the max of phi and one? It's phi. You are allowed to do one operation, k equal to 1. So guys, which one you will reverse? Obviously you will reverse the middle part, right? If you reverse the middle part, the rest of the parts will be smaller. So change this 0 to 1. One operation done. Now the blocks are this block of size 2, this block of size 1, this block of size 2, this block of size 1. So 2 1 2 1. The maximum is what? 2. So guys, earlier your block size was 5. Now the maximum block size is 2 after doing k equal to 1 operation. So basically you can do less than equal to k operations, and then all you have to do is, guys, try to decrease the block size as much as possible. Such a nice interesting problem, right? So now let's see what can we do. Let's do a little bit of more analysis. So guys, now binary string is nothing but continuous continuous blocks of 1 and 0 or 0 and 1. If the length of all these blocks is less than equal to g, guys, at some moment of time, then we can know that the answer for less than equal to g is possible. Okay, so what I'm trying to show you people is that, let's say let's say this is my string. Okay, you know string is nothing but the blocks of zeros and ones, right? Zero, one, or it might start with a one block, something like this. Okay, like this. Okay, now like this, there are many blocks of zeros and ones, right? Now what I'm trying to say, let's say this is a binary string. If this block size is also less than equal to g, and this block size is also less than equal to g, then the maximum of them will be what? Maximum of them will also be less than equal to g. Basically, final answer of less than equal to g is possible if each block is less than equal to g. If each block is less than equal to g. Okay, that's the basic precedence. That's the basic observation. Let, let's say there are many blocks like this. Binary string is nothing but a block of 0 and 1, right? So guys, let's try to make many blocks and let's try to see what happens. So let's say some zeros are there, then some ones are there, then some zeros are there, then some ones are there, then some zeros are there. Let's say this is of size 5, 6, 7, 2, and 3. Okay, now all of them are less than equal to 7. This is also less than equal to 7. This block size also less than equal to 7. This block size also less than equal to 7. This block size also less than equal to 7. This block size also less than equal to 7. So because all the block sizes are less than equal to 7, it means that the less than equal to 7 answer is possible. And guys, it is true. What is the answer for this case? Answer for this case is 7 only, and 7 is less than equal to 7. So I hope you got the second brilliant observation as well. Now guys, let's try to solve a test case. Okay, let's try to solve a test case for k equal to 1. Okay, for k equal to 1. Okay, so guys, be ready with me. We are going to solve a very very important test case. So guys, see, we want the minimum g possible, right? So first I will try the answer for g equal to 1. If it fails, I will try for g equal to 2, g equal to 3, g equal to 4, g equal to 5. Just a linear search. So let's say this is my 2 3 4. Okay, okay, 5. 1 2 3 4 5. Okay, now guys, you can see that this block size is what? 1 2 3 4 5 6 7 8 9 10 11. Okay, this is 11. Okay, this is 2, and you can only do one operation. Let's try for g equal to 1. Guys, g equal to 1 means the string should either look like 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1, like till the end, Or the string, see, g equal to 1 means after every block size should be 1 only. 1 0 1 0 1 0 1 0 1 0. So guys, if you try to make it 0 1 0 1 0 1 0 1 0 1 0 1 0, you have to make so many changes. One change here, two change here, three change here, four change here, five change here, six change here. Total six changes you need to make for g equal to 1. Total six changes are required. You can see one change, two change, three change, four, five. Then six changes are required for g equal to 1, which is not allowed. We are only allowed k equal to 1 change. So g equal to 1 is not possible. Okay. So guys, why g equal to 1 is not possible? You can try with both the strings, either 0 1 0 1 0 1 or 1 0 1 0 1 0. Whichever gives the minimum number of changes, take that number of changes and see if that changes is less than equal to 1. So guys, g equal to 1 is not working because it cannot be done in k equal to 1 operation. Now let's try for g equal to 2. For g equal to 2, what is going to happen, guys? G equal to 2, right? So, two zeros can come, but after that, there should be a change. So, two zeros can come, but after that, you need to cut it and you need to make it 1. Again, two zeros can come, but after that, you need to cut it and you need to make it 1. Two zeros can come, but you need to cut it and you need to make it 1. Two zeros can come. Okay, but here you need to cut it and you need to make it 0. No, no, it's fine. Na? Two ones are fine. Okay. So now, guys, you can see this block size is 2, this block size is 1, this block size is 2, this block size is 1, this block size is 2, this block size is 1, this block size is 2. Okay. So g equal to 2 is possible, but how many operations you need to do? You need to do 3 operation, guys. You need to do 3 operations. But we are only allowed to do 1 operation. Guys, can you see? For g equal to 1, you need to do 6 operations. For g equal to 2, you need to do 3 operations. Okay. And both are failing because we are only allowed to do 1 operation. So guys, what is the conclusion? G equal to 1 also failed, g equal to 2 also failed. Now let's try for g equal to 3, g equal to 4. So g equal to 3, yeah, 3 zeros. Then, I cut it up. I make a 1 here. 1, 2, 3. I cut it up. I cannot make sure, I have to make sure there are no more than 3 zeros. The continuous blocks should be of size less than equal to 3. Now it's fine, guys, but how many operations I have to do here? I have to do for g equal to 3, I have to do 2 operations. This is also failing, guys, because I'm only allowed to do 1 operation. So guys, I hope you can observe that as the g value is increasing, the number of operations are decreasing. So if I keep on making my G bigger and bigger, one time it will surely pass. So you can do linear search, binary search, because it is a monotonic function. G increasing, as it increases, operation decreasing, and if it operation keeps on decreasing, required operations keeps on decreasing. At one time, surely those number of operations will become less than equal to k, and you will find your minimum answer. Now, like the minimum answer of the longest length block possible, which means if all the block lengths are less than equal to g, then the longest block length will also be less than equal to g, and we assume, or we say that less than equal to g or g is our answer in our binary search function. Now anyways, let's go back to the problem. So guys, g equal to 3 is also not working. Now let's try for g equal to 4. For g equal to 4, what's happening? Okay, so for g equal to 4, 1 2 3 4. Okay, I need to change this guy. Then 1 2 3 4, I need to change this guy. So guys, for g equal to 4, in 2 operations we can do, but 2 operations are not allowed. We are only allowed 1 operation, guys. So guys, even g equal to 4 is failing. Now guys, we will use g equal to 5. 1 2 3 4 5. I change this to 1. So this block is of size 5, this block is of size 1, and again this block is of size 5, and this block is of size 2. So guys, in one operation only, this problem has been solved. K equal to 1 has been solved. In one change, all the block size have become less than equal to 5, and the maximum block size is of 5. So 5 is the answer. Why this happened? You guys know why this happened, right? K equal to 1. So if you are only allowed to do one operation, G equal to 5 will work out. Now because G equal to 5 is working out, obviously G equal to 6 will also work out. in these many operations. G equal to 7 will also work out. Okay, G equal to infinity or even the length of the string will work out. Once it starts working out, बेसिकली अगर एक ऑपरेशन में तुम सारे ब्लॉक्स की साइज लेस देन इक्वल टू 5 कर पा रहे हो, तो लेस देन इक्वल टू 6 तो आराम से ही कर लोगे ना, क्योंकि वो उसमें बड़ी लेंथ अलाउड है. लेस देन इक्वल टू 7 तो और आराम से. चलो लेस देन इक्वल टू n तो भी ऐसे ही हो जाएगा, क्योंकि ऑलरेडी सारे ब्लॉक्स की लेंथ लेस देन इक्वल टू n है. ओके, so I hope that this these observations are pretty clear in your head. Okay, I hope they got clear. So guys, what is the observation? Find the observation. Let's see. Students keep on getting selected all the time. It feels so good. Recently, you guys know a student who had a gap of 1 to 2 years, they cracked 15 LPO offer. So I'm so happy for them that even those kind of people are doing great in my program, in our program. So guys, for G equal to 1, it failed. For G equal to 2, also it failed. For G equal to 3, also it failed. For G equal to 4, it also failed. But for G equal to 5, it passed. Once it starts passing, once you become successful in your life, you will stay successful. Basically, if you are able to make sure that all the blocks are of less than equal to 5 size in k operations, then you can always make sure that it will work for all the block size less than equal to 6, all the block size less than equal to 7, until all the block size less than equal to n, which is the length of the string. Okay, so G equal to 5, it worked out. So what is the observation? As the G value increases, the number of operation needed decreases, and one day the number of operation required will become less than equal to k, and the answer will be true. So it is monotonic function for G. So guys, G function will look like this. Earlier G values will give false, 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 not working, not working, but one time it will give a true value, and then forever it will give you a true value. So basically, G is a FFFFTTT function. So G is looking like this. So guys, G is looking like this. If I make a bar graph for G, okay, let's say 1, 2, 3, 4, 5, 6 till n. Okay, so earlier it for one G equal to 1, it did not work out, false. G equal to 2 did not work out. G equal to 3 did not work out. G equal to 4 did not work. G equal to 5 it worked out. Once it starts working out, it's always true. So guys, you can just do a linear search na. First try for G equal to 1, does not work, try for 2, try for 3, try for 4, then try for 5. 5 it's working, that's the answer. But you can optimize by doing binary search. This is a standard binary search problem. You can Google or you can use ChatGPT, and you can ask that if I'm given a sequence of first all F and all then T, how can you use binary search to find the first occurrence of T? Well, if your mid value is coming here, you go and check in the left hand side for the first occurrence of T. And if your mid value is coming on F, then obviously the first occurrence of T is on the right hand side. So with the basic prerequisites, the knowledge of binary search, you can do it. I will try to attach some of my course videos of binary search. You guys can watch it. Okay. So you can just do a binary search on G. So guys, most of the problem is solved, but one thing is still left. What is that thing? One thing is still left. What is that thing, guys? That thing is, that thing is, that thing is that how will you know that if a particular G works or not? Guys, once you find it out, I think it is intuitive. You know what to do, right? When you're traveling, you just check, right? Let's say zeros are there. Zero came G times. Now stop. Change the next character to one if it is zero, and keep on doing this process, right? But there is a little bit of flaw with that process, and let me explain you what is the flaw. Like in normal cases, it will work brilliantly, guys. Let me show you. So let's make 0, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6. Yeah, so yeah. So there guys, there are 6 zeros, right? And there are 2 ones, okay? Now guys, lovely people, listen up, listen up, listen up. Okay? Listen up to me. Now, let's say that you are trying to achieve the answer for G equal to 4, okay? Check function you are making, basically check of G, check of 4. Basically tell me, for 4 it is true or false. Is it possible to make sure all the block sizes are less than equal to 4 and k is equal to 1? So what will you do? Just keep traveling here. Okay, this is this, this is this, 1, 2, 3, 4. Okay, 4 times 0 came in the for loop. Now I will change it, I will make it 1. So I will increase my counter, that one change I've done. This is 1, this is 0, so no problem. So guys, this size is of 4, this size is of 1, this size is of 1, this size of 4. So guys, all the blocks have become less than equal to 4. So obviously the maximum will also be less than equal to 4. So yes, it's possible. True. So guys, our basic algorithm is pretty clear, right? करना ही क्या है तुमको? वो 0 1 वाले बाइनरी स्ट्रिंग को ट्रैवल करो. ट्रैवल करते वक्त समझो जीरो पर, तो देखो कितने जीरो आ गए। अगर के जीरोस हो गए हैं और उसके बाद भी लाइक अगर जी जीरोस हो गए, इफ जी जीरोस हैव हैपेंड और उसके बाद भी एक जीरो है, तो उसको चेंज करके वन कर दो और वही एल्गोरिदम चलते रहो। समझो जी वंस हो गए, उसके आगे भी वन है, तो उस वन को बदल के जीरो कर दो ताकि कहीं भी कोई भी ब्लॉक जी की साइज को क्रॉस ना कर दे। If I try to repeat it in English, you're just traveling the string, right? You know, it's a continuous blocks of zeros and ones. So whenever you are in the zero territory, just keep a count of the continuous zeros coming up. If that count exceeds G, right there and then, you change that character from 0 to 1, and same for 1 to 0. Okay. But guys, there is a minor flaw in this problem, minor flaw in this approach, which makes a problem a little bit more difficult. So now, the difficult and the interesting part is that this much is clear to all the people, but there's a case where it gives the problems. The case is 1 2 3 4 5 1 2 3 4. Yeah, most people would not be explaining you this case, but I am doing because I intuitively feel your feelings. My job is to make sure you become so stronger intuitively that nothing in the DSA world, scares you. Now, 0 0 0 0 0 4. So guys, G equal to 4, you have to check true or false. One operation allowed. So what will you do? 1 2 3 4. Then what will you do? Okay, sir, I will change this one. But now, guys, whenever you do operation on the last character of the block, it messes up the whole procedure. Why? Now it has become 1 and this one is joining with this block. So 1 2 3 4. I will again make a change here and make it 0. So guys, total two operations are needed, but we have only one operation. So we will say the answer is false. So guys, did you see in this case what happened? Everything is good, but I am making the change of character at the last character of the block. When you make the change at last character, it problem can happen. It can happen that the other block was of 1 or 0 was also of size, let's say G, and this one joined with that and made it G plus 1 and increasing the operations further on. So here you are requiring two operations, but you can do in one operation also. How? Rather than changing this guy, what you could do brilliantly is never change the last character. If you have to change the last character, instead of changing the last character, change the second last character. You make this one. So what will happen? This block of length 3, this block of length 1, this block of length 1, and this block of length 4. Yes, all are less than equal to 4. It's working in one operation. True. Guys, can you see the brilliancy? Such a brilliant, great, lovely problem. Instead of changing last character, always change second last character. And this works for G equal to 2, 3, 4, 5 till the end. For G equal to 1, don't do this. For G equal to 1, you know how to solve. Make one string of 0 1 0 1 0 1, make one string of 1 0 1 0 1 0, and with both those strings, compare what's the answer coming. But for G equal to 2, 3, 4, 5, you can, instead of changing the last char of the block, you can always change the second last char and get your job done. So what will be the formula for that? So guys, instead of changing the last char of continuous block, if needed, always change the second last char. So guys, see, the formula will be pretty simple. Let's say you have a block of zeros and ones, right? Right. So let's make it easy for you people, okay? So 1 2 3 4, and then this is the string, right? What is the size of this block? The size of we are trying for G equal to 4. We're trying for G equal to 4. Okay, we're trying for G equal to 4. So size of this block is also 4. So guys, if the size of the block, okay, if size of block is less than equal to G, do not do any operation, guys. It's common sense. The size is always already less than equal to G. तुम ही सोचो ना, अगर कोई ब्लॉक ऑलरेडी जी से छोटा है तो उसको क्यों कुछ कर रहे हो? दैट्स नॉट गिविंग यू एनी प्रॉब्लम. द ब्लॉक शुड नॉट एक्सीड जी. So guys, if it is less than equal to G, then don't do any operation. The answer is true. You can solve in zero operation. Don't do anything. Everything is less than equal to 4. But guys, what if, see, if the block size is 4, it takes zero operation. But guys, if the block size is 5, it will take one operation. Why? Now 1 2 3 4 5, you want to do the change at the last character, but instead of last character you do here. So no problem happens with this guy. So one operation is needed for 5, right? Guys, what would have happened if this was of size 6? Then also 1 2 3 4 5 6, yeah, you can do one operation here. So guys, for 6 also it's taking one operation. For 7 also it will take one operation. Even for 8, you can do here. See, this will become 4 and this will become 3 and all will be less than equal to 4. So for 8 also it takes one operation. You know the nice thing, even if the block size is of 9, it will take one operation only. 1 2 3 4 5 6 7 8 9 and 2 ones. So you can divide this to 4 and this to 4, and in the middle you can make it 1. So guys, even so guys, if the block size, you will check each block. If the block size is less than equal to 4, obviously no operations. But if it is more than that, guys, answer is nothing but what? Block divided by g plus 1. So if the block size is 5, you divide by 4 plus 1. 5 by 5, 1. One operation you have to do. Block size is 6, 6 by 5. 7 by 5, 8 by 5, 9 by 5. Now when it becomes 10, when it becomes 10, 1 2 3 4 5 6 7 8 9 10, 1 2 3 4 5, तो यहाँ पर एक बदलने का 1 होगा, 1 2 3 4 5, तो यहाँ पर एक 1. बट never do 1 on the last care, right? Always do it at the second last care. So now guys, this is of size 1, this is of size 4, this is of size 3, this is of size 4. So it's all working out. So guys, just check the size of this, and the block size divided by g plus 1 is the answer. Okay, that is the number of operations needed. Okay, so guys, block size, guys, the problem has been solved. You will just travel the strings, check the size of all the blocks of 0 and 1. Now do block size divided by g plus 1, that is the number of operations needed. Once you calculate the total number of operations, if the total number of those operations is less than equal to k, answer is true, else it's false, and the problem has been solved brilliantly now. So what to do, how to do? If the size of the block is less than equal to g, don't do any operation. If greater than g, operation required will be block divided by g plus 1. Calculate and add the total operations for each block. If the total operations, if total comes less than equal to k, answer is true, else false. And the time complexity will be n time, your check function, and log n time for your binary search, right? And coming to the space, so I don't think any extra space is required, right? Binary search requires no space. Checking the blocks also takes o of one size, as no extra size or space is used. Okay, so you will get the C++, Java, Python codes very soon for this. And guys, make sure you like and subscribe if you want regular high quality content like this on this channel. Take care, all the best. Hope you guys are enjoying this Sunday. And yeah, Ram Ram.